Okay, so now let's look at velocity at an instant. We're still looking at velocity time graphs. Now I want to look at how we can find velocity at a particular point in time. Right. For example, for the journey shown, find the velocity at 3 seconds and at 15 seconds. So this is the journey here. We want the velocity at 3 seconds and we want the velocity at 15 seconds. So how do we work through this? Well, first things first, let's start off with the velocity at 3 seconds. Right. If we are to map our 3 seconds, this is a 4, so our 3 would be somewhere here, right? So we are looking at the velocity there, right? What's the velocity here at that point there at 3 seconds? Well, the simple thing is to first of all ask yourself, what is my acceleration in this region here, right? You must first of all look at the entire region from start to finish, where it starts and where it ends, beyond that point that you're looking at. And then you ask yourself, for that region, what's my acceleration? What's my acceleration? Now, acceleration for this region, we can easily calculate it. We calculated it earlier on. A is equal to V2 minus V1 over T2 minus T1, which is going to be our change in velocity, 24 minus 0 over 4 minus 0. So it's going to be 24 minus 0 over 4 minus 0. That's meters per second. That's seconds, which is going to give you 6 meters per second squared. So for that region, acceleration is 6 meters per second squared. What does that mean? It means that speed increases by 6 every second. So since you are starting from 0, right, here, and this is 3 seconds, speed is going to increase 3 times. 1, 2, 3, right? We're going to start off at 0. So our velocity at 3 seconds is going to be equal to our starting point 0 plus 3 seconds times the acceleration, which was 6. So which is going to give us 0 plus 18, which is going to give us 18 meters per second, right? Really, this is what happened. Speed was at 0. We know that acceleration is 6 meters per second squared. So acceleration increases by 6 every second. So for 3 seconds, 6 plus another 6 will give you 18 meters per second. So that's our speed at that point. All right. So now let's move forward now. Let's try finding velocity at 15 seconds. And we said, again, the first thing you want to do is to say, okay, where is my 15 seconds? So let me use maybe blue. Just clear this off so that we make more room. You make more room for that. So I'm just clearing this off so that it's clear. So now we're looking at 15 seconds. So 15 seconds is somewhere here. So there's our 15. Goes up. We're looking at something like that there. What's the velocity at 15 seconds there? Again, you must look at the whole region, where it starts, where it stops, and ask yourself the same question. What is the acceleration of that region, right? Where does the region start and what is the acceleration of that region? So if you calculate the acceleration for that region, it's simple. It's V2 minus V1 over T2 minus T1, which is going to be equal to, if you look at it here, it was 0 minus 24 over 16 minus 10. 0 minus 24 over 16 minus 10. So this is meters per second, that's seconds. So acceleration is equal to minus 24 over 6, that's meters per second squared. Now it's going to give you minus 4 meters per second squared. So our acceleration now is minus 4 meters per second squared. That means speed is dropping by 4 every second, right? So if you look at that region, the region is going to start at 10 seconds here, right? Where the speed is 24. And then the speed is going to drop 5 times because from 10 to 15 is 5 seconds. So 1, 2, 3, 4, 5. Every second is dropping by a 4, dropping by a 4, dropping by a 4, dropping by a 4. until it gets to this particular velocity, because our acceleration is -4, right? Meters per second squared. So we're going to have 24 minus 4, 5 times, right? Our velocity at 15 seconds is going to be equal to 24 minus 4, 5 times, which is going to be 24 minus 20, which gives you 4 meters per second. So by the time you get to 15 seconds, your velocity is going to be 4 meters per second here. So our velocity there will be 4 meters per second. Okay, so that's it. That's pretty much what you have to know about velocity time graphs. The only thing that you need to take note of is that the shapes of the velocity time graphs can be different. You can get a shape like this one here, or you can get a shape like this one, or any other shape. They don't always start from 0. This one starts from 0, this one doesn't, right? They don't always go up. Some are sort of going down from where they start. So work with whatever shape you have, but use the same principles. Don't change the principles because these shapes look different. Don't change the principles. Use the same principles. They will work and they will give you the correct answer regardless of the shape.